The Earth is not static. Mountains rise and subsidence occurs, allowing for the accommodation of kilometers of sediments. How does this work? Our discussion of vertical movements is based on the principles of isostasy. We state that in conditions of equilibrium, the weight of the lithospheric column above the compensation depth must be the same everywhere. In other words, topography is a function of the weight. If the thickness and/or density of the lithosphere changes, then vertical movements are expected. The most common way to change the weight of the lithosphere is by extension or by shortening. By extension, the lithosphere will tend to become thinner. By shortening, it will become thicker. In the following, we will only look at what happens with extension. Applying the same rules, you can easily predict what happens during shortening. The following discussion is somewhat complicated, so I need all your attention. This is how we will do it. We will look separately at the behavior of the two fundamental components of the lithosphere, namely the crust and the lithospheric mantle. For each component, we will look at the vertical movements during and following extension. At the end of the clip, we will integrate the two components, predicting vertical movements of the Earth's surface in rifty basins of different characteristics. The crust is the easy bit. During extension, the crust will become thinner. In terms of isostasy, thinning of the low-density layer imposes downward movement and the surface of the Earth will subside. After the end of extension, no thinning takes place anymore and no vertical movements are predicted. The behavior of the lithospheric mantle is more complicated because its lower boundary is an isotherm and not a material boundary as the MOHO. The result is that vertical movements will depend on how fast thinning occurs. At the beginning of the experiment, the isotherms of the LAB are flat, and we consider the evolution of a rock initially situated at the depth of the 1300 isotherm. During thinning, the rock will move upward, for instance, of 30 kilometers, and will then end up at 90 kilometers depth. The question is then, what temperature will the rock have when it reaches its final depth? If the movement is very slow, the rock has all the time to adjust its temperature to that of the surrounding rocks, and when at 90 kilometer depth, will have a temperature of 1300 degrees. This means that the isotherms will not move. Because the MOHO has moved upward, slow movements result in the thickening of the lithospheric mantle and, therefore, generalized subsidence. Following the end of extension, the flat isotherms will remain flat and no vertical movements are expected. If, on the contrary, movement is very fast, the rock cannot equilibrate and will preserve its initial temperature of 1300 degrees during movement. This means that the 1300 degrees isotherm will have experienced substantial displacement, creating a large thermal anomaly. The thickness of the lithospheric mantle will not change or might even decrease. This will translate in little vertical movements, maybe even some uplift. Following the end of extension, the thermal anomaly will not be supported anymore by extension and will decay. The lithospheric mantle will become thicker and subsidence will take place. This despite being after the end of rifting. Let us now put together the behavior of the crust and of the lithospheric mantle. First, in the case of slow rifting. During thinning, the crust will always want to create subsidence. If extension is slow, further subsidence will be added by the lithospheric mantle, resulting in very important downward movement. Following the end of thinning, nothing will occur. If extension is fast, then the subsidence imposed by the crust will be partly compensated or even overruled by the lithospheric mantle. Important posterior subsidence will take place when rifting was fast. Yes, I admit predicting vertical movements is not always easy, but it's important and is needed to understand the formation of mountains and basins.